Hello, welcome back. We are on our next part of our EOC review. This is the third review. This is part 2 of that third review. So let's dive right in. The first thing we're talking about today is going to be graphing linear inequalities. Okay, so remember, an inequality versus an equation. In an inequality, you have a less than or a greater than, or could also be less than or equal to, or greater than or equal to, but you absolutely, unequivocally do not have an equal sign. Okay, that's the big difference here. When we are graphing linear equations, we just draw a line on the graph and connect the points, and we're done. In a linear inequality, you have one part of that line is shaded, either above or below, and that all depends on if it's a less than or greater than. So let's jump in and do one. We're going to look at our first example here, which is y is greater than negative 3x minus 1. So we need to take the line negative 3x minus 1, graph that, and then since y is greater than whatever that line is, we're going to be shading above that line. So let's go ahead and graph that. If this is in slope-intercept form, quote unquote, then this in slope-intercept form, whoops, we don't want a drawing, we want a shape. Un segundo, por favor. Okay, this would be y equals negative 3x minus 1. And you know how to graph that because you just go to negative 1. Okay, this is like, the scale here is a little whacked up, so we're gonna, negative 1, let's see, this is 1, 2, 3, okay, yeah, so it would be here. That's negative 1, that's the y-intercept, and then you use the slope, negative 3 over 1, to go down 1, 2, 3, and to the right 1. And if I did it again, down and then to the right 1, I'd be off the graph, so let's go the other way. I'm going to go up to 3 and to the left 1, up 3 and to the left 1, and there is our line. Let's use my shape tool here to connect this line. Let's see if I can do this correctly without just messing it up. That looks pretty good, actually. I'm not gonna lie. Okay, so the only question that should be on your mind now is, well, how exactly do I choose what's above and what's below? Okay, so if you, and I wanna like check the video so I can see my own arm here and see if this is right. Okay, so pretend this is a straight horizontal line right here, okay? It's easy to tell what would be above or what would be below that line. Now, a line that we draw on a graph typically has a slope to it, right? So it tilts this way or it tilts this way. But if you follow that tilt, the above is still in the same place, okay? So like the line that we just drew here, the shading would be, and I will use, let's use like a highlighter here to do this. If I were to take this line and tilt it back to 0, right? Then the above part would be over here. It would be above the line, okay? And that's where you want to shade. So on questions 2 and 3, I need to see your shading, okay? And you need to make sure that you're paying attention to what's above and what's below. One more thing to note, and I missed this, myself. You have to pay attention to the symbol that's being used in your equation. If you have a greater than or a less than, then you need to use a dash line. And if you have a less than equals or a greater than equals, then you need to use a solid line, okay? So I didn't even use the correct line here. I wonder if I think I can make this into a dashed line. Let's see. Wonder if why isn't it tapping? Aha. Aha. Okay, I made it into a dashed line. Problem solved. Okay, great. So when you're drawing it on paper, you can just go back and erase some of the segments so it looks dashed or whatever. Go ahead and just check yourself right now, look at 2 and 3 and decide Are these going to be dashed lines or solid lines? And draw yourself a note so you don't forget that part, okay? All right, so 2 and 3 are up to you. Graph those lines, shade them, make sure you put dashed or solid. All right, the next thing is systems of linear inequalities. So this is no different than when we were doing systems of equations, right? We're just going to graph the two lines, okay? And then we're going to shade each of them individually, just like we did in the last problem. And then we just need to choose what is that region where the shading overlaps, and that's where your solution section is. Okay, so let's use, how about, what's two colors that would look good over, let's use blue and orange, all right, because go Gators. So let's do number 1 here. I'll make sure this all fits. Great, okay. So the first line is going to be blue. Second line is going to be orange. Actually, we should use blue and red because I think that's going to make purple. Yep, not an art person. Blue and red. Okay, so the second line will be red. All right, let's graph them. I need to get them into slope-intercept form first because that's the easiest way to graph. So let's look at the blue equation first. That's x plus y greater than -1. I need it to be in the form y equals mx plus b. So let's get rid of the x off of both sides. Then we get y greater than -x minus 1. Now that is slope-intercept form, because in slope-intercept form it would be y equals -x minus 1. Okay, so let's graph this. This would be starting at -1, and then we use our slope of -1 to go down and to the right, down to the right, down to the right, or up to the left, up to the left, up to the left. And let's go ahead and do a nice line here. Is this going to be a dashed line or a solid line? It will be dashed. Can I make it dashed through here? Apparently, I cannot until I actually draw it. So whatever, let's just draw it. So that's going to be like, ooh, that's like a terrible line. So let's fix it, right? Okay. First of all, it's dashed. And second of all, this side needs to be angled up a little bit better. And this one needs to be angled down a little better. Okay, that's a lot better. Okay, so that's good enough. Oh, actually it's not, because that needs to go all the way. Otherwise, I'm not going to know where to shade. Okay, that is pretty good. Oh, man, hold on. This drawing tool is like more effort than it's actually worth. Okay, looks good. Oh my gosh, why does this keep happening to me? Okay, one more time. Okay, close enough. Hopefully I don't touch it again and it won't mess up. Okay, we're using red for our second equation. Our red equation is x minus y greater than 8. So we need to get the x over there. -y, -x plus 8. But we can't leave this as -y. It needs to be a positive. So, because that's what slope-intercept form tells us. So if I make this, switch the sign for y, I need to switch the sign for everything else. So this is actually going to be y as less than x minus 8. Pump the brakes. Why, W-H-Y, I'm asking you a question now. Why did I change the sign of my inequality? You should remember this already from a previous lesson from when we solved inequalities. Anytime that you multiply or divide by a negative number, you have to flip that sign. What I'm actually doing when I change the sign of everything like that, like the negative and positive, is I am dividing everything by -1 or multiplying everything by -1. Either way you look at it, it's the same operation. But because that division and multiplication by the negative number is happening, that means I have to switch the sign. I have to flip it around, okay? So let's go ahead and graph this now. I'm going to start at -8, and then my slope is +1. So 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, or the other way, down and down. And I'm going to take a stab at this line tool again. That's looking pretty good. Let's use our select feature here. Now, where's the thing that there we go. All right. This is going to be a dashed line with arrows. And I just need to like make the angle a little better. Okay, it's perfect. And I'm oh man, see, I thought it was going to be nice and easy, but it's not. Okay, realistically, this is really not difficult to do. I'm just, I keep messing up because I'm using a stylus probably. I'm sure you remember we had these difficulties in class also. Okay, I'm done. I'm not touching it. Okay, next thing we need to do, this is actually the final step, is figuring out where the solutions are. So go to your blue line. Let's talk only about the blue line right now. Is it above the line or below the line? Y is greater than the line, so it's above the line. So with a blue highlight, I'm going to shade in all of this space here at the top above the blue line. Okay, that looks pretty good. If you're a perfectionist, you might go back and like really fill in all the little cracks there, whatever. Oops. Where's the undo button? Whatever, I can't find it. Okay, so the other thing I need to do is I need to, with a red highlighter, now go and do the other line. The other line is a less than, so I need to shade underneath the red line. That's going to be this region down here. Okay, it shouldn't be hard to tell now where the two regions are intersecting, okay? The two regions intersect here. Everything in this little section right here, or if I were to blow this graph up and make it bigger, everything that is where those shading intersect each other is the solution to this linear inequality. Why would I be shading an entire region? Let's think about this. Because you can pick any point that's inside of that region. You can pick +10 minus 2, or you can pick +9 minus 7, or you can pick +11 minus 5. Whatever you pick, if that point is in that section, it will make this system true, okay? So that's the whole purpose behind this. I believe that I have... Yeah, okay. So I'm going to do one more with you, and then you guys are going to do 2 and 4. So let's zoom in on number 3 here, and let's make the magic happen. So I think red and blue is probably good choices, right? So let's just do that again. We're going to use blue for the first line, and we will use red for our second line. We'll do the blue first. We need this in slope-intercept form. Oh, I just wrote an equal sign because I'm an idiot. Whoops, sorry. Okay, so greater than equals 4. Done. Okay, so in slope-intercept form, the x would be on the other side. So cancel that out. Y, -4x plus 4. I did not flip the inequality because why? Ask yourself this question. The reason I didn't do that is because I didn't multiply or divide by a negative. I was just adding and subtracting, and that doesn't have any impact on it. It's only when you multiply or divide, okay? While I'm here, before I even graph it, let's just do the red one too. That way I can just do everything at once. 3x minus 2y greater than 14, minus 3x minus 3x, negative 2y greater than negative 3x plus 14. Okay, I need to divide by negative 2. There should be alarms going off in your head right now because I'm dividing by a negative. So what is happening? I need to cancel that out. Y is less than. I need to flip the sign. And this will be negative. No, it'll be positive. I lied. Negative divided by negative is a positive. 3 halves x minus 7. Okay, let's graph these lines. So the blue line starts at 4. We go down 4 and to the right 1. Down 4 to the right 1. Let's go the other way too. Up 4 to the left 1. Okay, I have enough points. I really just need 2, but I have enough points to do a line. And let's make this beautiful line this way. Hey, I'm getting better at it, I think. That looks pretty good. I just need to fix what? Well, really, I just need to add arrows to it, but I'm afraid to touch the line. I'm not gonna bother. Here, I can actually just draw them. How's that? Arrow, arrow. We like that? Cool. Okay. So that is the first line question. Do I shade above or do I shade below? It is greater than, so I'm going to be shading above the line. Let's go ahead and fill all this in with our blue. Let's see, did I fill it all in? I think I did pretty much. Okay, let's do the red line now. So red line, start at negative 7. You're going to go up 3 and over 2. Up 3. Oops, that's not too many. Whoops. Boop. Uh-oh, I messed up because I erased the highlighting as well. Oops. Whatever. Guess what? We can redo it. That obviously won't happen to you if you're using pen and paper, but it happened to me because of technology. Okay, so that's enough to do that line. Let's wrap it up. So we need to draw this red line. That's pretty good, except this end needs to be a little like, and this one needs to be a little, and that one, okay, we need to go back and, uh-oh. Okay, that's pretty good. Except I keep messing up. Well, not only that, but I need to make it dashed actually while I have this window open here, so. Okay. We'll add the arrows because why not? All right, now let's fix the ends one more time. Obviously, this technology will not be bothering you while you do this on regular paper, but if you use Cami, you're going to have the same problems that I'm having. Okay, that looks pretty good. I'm not going to touch anything else. Ugh. You're probably over there on that screen right now saying, Mister, let's just stop. Okay, I'm done. I'm not touching it anymore. Okay, all I need to do is shade because I accidentally erased my shading. Remember the blue was above this line. So we need to fill in, hopefully without picking the pencil up again, we need to fill in all this with blue. Okay, and then we need to use red for the other line. This is less than, so it's going to be under the red line, okay? Under the red line. Careful when you're doing your little intersections there. Make sure that you're shading completely under the correct lines. Okay, so it's pretty easy to tell now where the area of intersection is. It is here. All this is a solution area. If you pick any point from that area, it will be a solution that satisfies this system. Okay, 2 and 4 are for you. Those questions take a while, so there's only 2 of them. Let's move on to the next topic of this EOC review, which is exponent rules. Okay, exponent rules. I think we did a review on that like pretty recently, if I'm not mistaken. Let's grab a drawing tool here. Let's do blue because we like blue. Okay, let's refresh ourselves on what these rules are. When you have a product rule is the same base and different exponents, what do you do with the exponents? You add them. So this will be x to the a plus b power. When you have a power rule, you have to distribute. That's one way to think about it, is like distributing. This power goes to everything inside the parentheses and you multiply. So this will be x to the a times b power. You can also do a quotient rule. What this means is minus. So this will be x to the a minus b, the top exponent minus the bottom one. The negative exponent rule, okay? Remember, this is the same thing as saying x to the negative a power divided by 1, okay? Negative exponents, if they're upstairs, they can go downstairs, and if they're downstairs, they can go upstairs, and you change that sign. So let's take this whole expression, move that sucker downstairs. First of all, what's left on the top now? It's just 1, okay? All that's left on the top is just 1. On the denominator, you have 1 times x to the a power, x to the a. This exponent is now positive because that's the power of moving it upstairs and downstairs, okay? All right, let's do some examples. The ones that you see in orange are your example problems that you're going to do for classwork. Okay, so let's look at the first question, numero uno. V to the 4th times 7v to the 3rd times 5v. Okay, numbers first, coefficients, right? So we have 1 times 7 times 5, okay? I'm able to combine those because they're all like, sort of like terms because it's the same variable. So 7 times 1 is 7, and then 7 times 5 is 35. That's numbers first. Then work with the exponents. So you have v to the 4th times, so I'm going to cross this out because I've done it already. Done. All you have is v to the 4th, v to the 3rd, and v to the 1st, and the product rule tells me I need to add them together. 4 plus 3 plus 1 is 8. 35v to the 8th power. Done. Okay. Number 2, I'm going to make my pen a little less thick too so it's easier to see. Number 2, let me zoom, is a 3x squared y squared inside parentheses, and that's to the 3rd power. So you need to take this sucker and it goes to every single thing inside here. It goes to the coefficient, it goes to the x squared, and it goes to the y squared. So this is 3 cubed times x squared cubed times y squared cubed. Okay, that's one way of looking at it. 3 squared is, 3 cubed is 27, not 9, my bad. 27. Okay, and then x squared to the 3rd is 2 times 3, which is x to the 6th. Y squared cubed is y to the 6th. So, that answer is fine with me. It's fine. It's logical. It's an okay argument. You left the multiplication signs. You're good to go. Really, you can cut them out. You can just put 27x6y6 like this. Okay. 3 is yours, which means 5 is ours together. 4 is also yours. So we have some stuff going on in the numerator and some stuff going on in the denominator. So we need to see, first of all, are there any negative exponents? The answer to that is no. So nothing needs to move from like upstairs to downstairs. Now all we need to do is apply the quotient rule. Okay, so let's look at a first. 6 divided by a to the 6 divided by a to the 5th means you have a to the 6 minus 5 power. And then you have b 7 over b to the 4th, which would be b to the 7 minus 4 power. Okay, and then you have c, which is c to the 2 minus 2 power. Interesting, right? Okay, so let's simplify this. 6 minus 5 is 1, a to the 1st. 7 minus 4 is 3, b cubed. 2 minus 2 is 0, so c to the 0. Trick question. What is anything to the 0 power? It's not 0, it's 1, okay? X to the 0 is 1. Anything, this is a rule, this is the 0 exponent property. Anything to the 0 is 1, so you need to fix that to be a 1. This is now a, we don't have to write the 1 exponent. Another little trick that we leave off things in math all the time, right? Times b to the 3rd, that's it. Because anything times 1 is just itself, right? That's a property that we learned before, isn't it? Yep. Okay, another strategy you can apply for a problem like this, which is one that I find helps if you are having trouble with like remembering the rules, okay, is a to the 6th. Another way to represent a to the 6th power is a times a times a times a times a times a. It's a times itself 6 times. So that means I have a on the numerator and a on the denominator. This is just the a part right now, okay? You could do it with the b's and c's also, but this is just a visual representation. So the thing is, like, stuff that's in the numerator and the denominator that's the same will cancel. So if I start canceling a's, every pair of a's that I find cancels out, and all I'm left with is a over 1, which is just a. And isn't that what I got in my original answer? Yeah. I mean, I need to do it for b and c also, but you know, this is a longer method certainly, but this is another way to look at the quotient rule and how that works. Okay. The rest of the problems in this section are yours. You really shouldn't have an issue here following these rules and combining, you know, the examples we did already with the ones you see on the page. So good luck. Is this the last thing? Yeah, this is the last thing in the review, which is simplifying polynomials. So remember, a polynomial is a collection of terms that are added or multiplied or subtracted from one another or divided that have a coefficient and a variable, okay? And all the terms have coefficients and variables. So that's the difference here. We're mixing up these exponent rules now with using variables and simplifying these polynomials. So what you want to look for is to like combine things that are like terms, all right? So let's look at the first question. First question, it says, this whole polynomial plus this whole polynomial, okay? So this function plus this function, f plus g, right, would just be all of these terms, 5 plus 2, I think it's cubed, but I drew over it, so yeah, it's cubed, okay. Cubed plus x minus 3x squared, all of that, and then this sign in the middle could be a minus. Sometimes it is minus. I think number 2 is a minus, okay. You need to distribute that sign to everything inside these parentheses. So this will still be plus 4x cubed plus 11 minus 6x, because positive times negative is still negative, and then plus 7x squared. Now all you do is combine the like terms. That's it. So let's look at the things that are like terms. Let's start with our highest exponent first. All right. So this has a cubed. This has a cubed. That's it. So the two things that are cubed put together would be 4x cubes, and 2x cubes. I have 4 of them and 2 of them, which means together I have 6 of them. So 6x cubed is the first thing. I'm going to switch colors for this. The next exponent down would be squared. So take this thing that's squared and this thing that's squared and combine them. Negative 3 plus 7 is positive 4. So plus 4x squared. I have negative 3x squareds and I have plus 7x squareds. Combine them, you get plus 4x squareds. Okay, I'll switch colors again. I think I didn't use green yet. Next exponent down would be to the first power. Remember, anytime that you don't see that exponent written there, it's 1. It's to the first power, because anything to the first power is just itself. So this would be really x to the first, and this would be really x to the first. So this and this are like terms. Plus 1 minus 6 is minus 5x. That's it. You could put the first if you want to, but your final answer needs to not include that first power. Anything to the first power is itself. That's why we don't write that first power as an exponent. Okay, the last thing that can combine, purple, why not? That's going to be this constant. It doesn't have an x, it's just a number. And then this 11, just a number, not an x. So 5 and 11 makes positive 16. Let's rewrite our answer. No, let's not rewrite our answer, actually. It's fine. It's fine the way it is. The only thing you wouldn't do is put this 1 exponent, so I'm going to just erase it. Okay? But that's your final answer. Bam. That is this simplified. Okay? Number 2 is a minus question. Number 3 is multiplication. 5 and 6 are multiplication, special multiplication. 7 is special multiplication. We'll do division together at the end. So let's do a special multiplication. That's number 4, okay? You have binomials that are being squared. When you have binomials being squared, you have to double distribute. You have to box method it. You have to FOIL it. You have to do any of these strategies I just mentioned, okay? One of them will work. In fact, they'll all work. Whatever one you're more comfortable with is the one that you should go with, right? So let's do it. Let's do it all 3 ways. Why not? Let's double distribute. So that would be x times x and x times 9. That would be x times x is x squared, and we're adding x times 9, which is 9x. Double distribute means that you do the first thing times those things, and then the second thing times those things. 4x, 4 times 9. Plus 4x plus 36. Is there anything I need to do here? Yes, there is. These are the same. They are like terms, so I can combine them to make it even more simplified. That would be x squared plus 13x plus 36. Okay, that's double distribute. Let's use a color I didn't use yet. How about orange? Let's do orange, and we'll do the box method. The box method, how many terms are in each thing? There's 2 terms in the first thing and 2 terms in the second thing. So I need a box that is 2 by 2, okay? Box, here it is, and it is 2 by 2. Take the first 2 terms, put them across the top. Take the second 2 terms, put them across the side. Does it really matter which binomial is on the top and which one's on the side? No, as long as you make sure that you're using all the terms that are associated with each other in the same place, okay? All right, now what you do is you just go row, cell by cell. So row times column, cell by cell, okay? The first thing is x times x, which is x squared, all right? The second thing is x times 4, which is 4x. The third thing is 9 times x, which is 9x. The last thing is 9 times 4, which is 36. Now, you just add all these terms, right? Are any of them like terms? Yes, they are. These are like terms, so those need to be mushed together. The rest of them are not, so you just add them up. X squared, 9 and 4 is 13x, and then plus 36. Notice how we got the same answer. I guess I'm not going to show you FOIL because I ran out of space. I kind of foiled, I guess, with double distribute. I mean, first outer, inner last. It's a little different than double distribute, whatever. It's the same thing. So 4 is done. 5, 6, and 7 are all the same type of problem. So choose to double distribute or foil, or choose to box method, whatever works for you, and get them solved. The last thing we have is a division problem, okay? So the first question here, and you might look at this and say, oh, this is simple. I can just cross this out. That cancels, right? Wrong. That does not cancel, okay? It does not cancel because these things on the top are being added or subtracted from each other, okay? If you had things that were being multiplied, okay, then that would cancel because division is the opposite of multiplication, right? If I had minus 6ab and plus 6ab here, yeah, they would cancel because minus and add, subtract and addition, right? Those cancel. But subtraction of 6ab, right, with all these other terms, and then you divide it by 6ab, like that doesn't work. It doesn't cancel out, okay? That's not the opposite operation, okay? Okay, but some things that we can do is we can maybe factor the top, right? Pull some things out they all the terms have in common. And then if I can do that, then I have things that are being multiplied. And if I have things that are being multiplied, then I can start canceling stuff out, okay? So let's see what we can do. Let's look at the numbers first on the numerator, numbers first. Do 18, 12, and 6 have anything in common, right? It's like a common factor. The answer would be, yeah, of course. They all have 6 in common, right? So I can factor out a 6. So if I factored out a 6, I have to go term by term and divide by 6 from that to find out what's left. 18 divided by 6 is 3, okay? The A and the B, I didn't do anything with that, so it's still there. It remains. Nothing changes. So it's still going to be A cubed B. The second term is 12, A squared B squared. What's 12 divided by 6? It's 2. So this is 2A squared B squared. And then what's 6 divided by 6? It's 1. So if that's the case, then I just have 1 AB, or more simply put, I really just have AB because we don't really need to specify that there's one of them, okay? This is all still divided by 6AB. So this is step 1. You can't see that. Yes, you can. Okay, switch colors. Let's do red. We're going to do step 2. Step 2, we're simplifying again. What else? We can't simplify any more numbers, right? But do they all have A's? This has A's, this has A's, and this has A's. Sure does. This has 3 of them, this has 2, and this has 1. So what's the most I could take out of all of them? 1. So this is going to be 6. 6 is still there. That's from the last step. That doesn't go anywhere, okay? I'm going to pull out 1A from everything. If I divide everything by 1A, okay, I'm not dividing by 6 again. I already did that. I'm only focusing on the A right now. A cubed divided by A would be A squared. Oh, I lied. Sorry. There would be a 3 there still. Sorry. 3. A squared. And we didn't do anything with B, so that stays. We didn't do anything with the numbers this time, and we didn't do anything with the B's. We're only changing the A's, okay? The 2 remains. A squared divided by A is A. The B squared remains. Finally, we have 1. We don't have to draw that. A divided by A is 1, so we don't have to draw that either. And then we have B left. All of this is divided by 6AB still. Okay, we probably just have like one more step to do here, right? So let me roll this up a little. Let's pick a different color. How about green? And we will do step 3. Okay, step 3. We still have 6A on the outside. The last thing that we have here is we have B's, okay? Do all of these terms inside here have a B in them? Yes, they do. So you're going to have 3A squared still, it's there. We're not changing anything about the numbers, and we're not changing anything about the A's. We're only looking at the B's. So there is 1B, Oh, I forgot to write my b on the outside. Sorry, hold on. Okay, so this should be a b here. And then we have 3a squared. B over b is 1, so that's it. Those b's are gone, okay? Next term, 2ab squared. 2a is still there. What about b squared? B squared divided by b is just b left, okay? And then finally, you have minus, and then b over b. B over b is 1. All right, now you do have to leave a 1 behind, and you have to do that because there's nothing else there, okay? All that's left is 1, all right? And then we divide all that by 6ab. Okay, question, did I find something? Now is my numerator a multiplication problem before it's addition subtraction? Yes, it's this times all this. But 6ab is on the top and 6ab is on the bottom, so they cancel because this is now multiplication. So this goes away, this goes away, and all I have left is 3a squared plus 2ab minus 1. That's my final answer, okay? So you really just have to, take a step back, slow down, do it bit by bit, and start pulling things out until you have enough things pulled out that stuff starts to cancel from the top and the bottom. That is what the goal is here, is to simplify. We're trying to get things canceled, all right? Okay, 9 is the last question. It's a similar type of problem, so you'll have to do this process for number 9, okay? That's it for the notes for this section. You have a Delta Math assignment that goes with this, all right? Remember, your score for this will be the problems we did together. That's a grade. The problems that are in the orange border here that are for you for classwork, that's a grade. And then the Delta Math is also a grade. And the Delta Math will include things that are from this chapter, this section. What else? There will be, on Friday, no instructional video posted. Friday, there will be a Google Forms style quiz posted in Google Classroom. You will have a week to do that. You need to get it done. Make sure that you are referring to the calendar that I posted that shows when the new topics will be posted and when they are due and when your last lesson will be. Okay, that's all I have for you guys. Thank you so much for tuning in and have a great day. I will see you next time. Bye-bye.